Okay, here is assignment 3-1 that we're going to do together. Just drop there. All right, so put down your title. Put down your name, the date, and your period. So when you take a picture of it, then I know who you are. Try to print neatly so I know it's you. And we'll start right away. Number 1. So number 1, you're given a function x at t equals 4t cubed plus 6t plus 2.5. And you're asked to do a bunch of things with it. So first of all, x means the position of the particle and t is in seconds. So A says find the velocity of the function. So we're going to use the letter v for that. And if you know the position to find the velocity, you just simply take the derivative of it. So simple power rule, 3 times 4 is 12, subtract 1 to the exponent. 6t will just be 6, and then 2.5 will be 0. B says, what's the velocity at 2 seconds? So all you have to do is substitute 2 in. You can use a calculator in your brain. 4 times 12 plus 6. Altogether, that's 54. And then we need a unit. So in the question it says the position is in meters per second. So there you go. Part C. You might think, oh, this seems very much like physics if you ever took physics. And you say, it's true. Calculus is the foundation of physics. They are inseparable brothers or sisters in all this. So physics is calculus, calculus is physics. They are very much connected to here. Calculus has more math directly involved, but physics is mostly all application. So the application of physics is using calculus as you go on in physics. All right, part C. Find the acceleration of it. So the acceleration is the derivative of the velocity. So 2 times 12, subtract 1. The derivative of 6 is 0, so it's just 24t. D. Find the acceleration at 3 seconds. We're going to substitute in 3. And then, so 24 times 3 is 72. Now units. Now, acceleration is the change in velocity over the change in time. So it's really, the velocity is meters per second, and that's per second. So the velocity, the change in velocity over, and often we write that simply as that, meters per second squared. But meters per second is how you would think through what acceleration is. So velocity is the change in distance over time. Acceleration is the change in velocity over time. And then we'd simplify this to meters over seconds squared. E. When is the velocity of the particle 18 meters per second? So I take the velocity, 12t squared plus 6, make it equal to 18, and then solve it. So to solve this, I'm going to subtract 6, divide by 12, and then when I take the square root, the answer could be either positive or negative 1. Now, when we have, and that's in seconds. So in real world situations, you can't have negative seconds, but there are conceptual physics situations where time could be both positive or negative in a conceptual sense. Obviously, in a real sense, time could only be a positive number. So unless you're told specifically, you'll answer it as a conceptual one, unless it's a real-world problem in front of you. So if you're given a word problem and it's obvious that you're asked about something very real, a car is moving, so on, then you'd have only the positive time. But if it's a conceptual question like this that's not connected to a word problem, then you'd answer both positive and negative. All right, F, find the velocity when it's 25 meters. So again, when the position of the particle is 25. So if the position is 25, then we make it equal to that. To solve this, I'm actually going to use my calculator. So hopefully you have this calculator. If not, you can just follow along. So for this calculator, if I want to solve something, I'm going to just start with the document. I'll start with calculate. And you can just either use the scratch pad that pops up, or we can create a document if it's a more involved question. But for this one, we'll just use the scratch pad that you see. So to solve an equation, I want you to press menu. I want you to go to algebra. And then I want you to go to solve. And then you're just going to type it in. So the equation was 25 equals 4t cubed. Make sure you use the alphabet at the bottom of the calculator. Exponent button is underneath the equal sign. And then when you press that button, it goes up to the exponent that's cubed. Move the cursor over. Then we have plus 6t plus 2.5. And then to solve it, we need to do comma. Now the comma is underneath pi. So find where pi is. Underneath pi on the bottom left corner, comma, then t. And then just go control. So press the blue button, control, and then enter. And it would solve it for you. So the answer is 1.5. Exactly. So I set it up. I used my calculator to solve it. So it's 1.5. But the question is, when is the velocity is that? So now we take that answer, 1.5. So it says find the velocity. So now we know the time, so it's 1.5. So now we take that answer and put it into the velocity equation. Again, you can use your calculator, but the answer is 33. Make sure you have units here, and it's 33 meters per second. G. Find the initial position. Now, initial position means you substitute in 0 for t. So if I substitute in 0 for t, it's pretty obvious. It's 2.5, what's left over, and we need a unit in our units in meters for position. So the initial position is at 2.5 meters, just by plugging in 0. Next question. Find the particle's displacement. So when we're asked to find the displacement, it's where you start compared to where you ended. So if I want to find the displacement from 0 to 1.15, then where did you end? So I plug in 1.5 into the position, subtract where you started. We already have that number, and that's it. So if you plug 1.5 into here, you can use your calculator, you would get the answer 25. We already know at 1.5 it's 2.5. So what's the displacement of this particle? Subtract it. So where it ended, and then you subtract where it started. That's displacement. And you get the answer 22.5. And again, we need units. So it's 22.5 meters. Done. All right, number 2. In number 2, a helium balloon. So now we have like not a conceptual question, but like a real world situation where we wouldn't have negative time. So a helium balloon rises, so its height is given by this. So S of t equals t squared plus 3t plus 5. So S represents the height. So, and then assume it says t is greater than or equal to 0. So it's a real world situation. So A says, when is the balloon 45 feet high? So this represents the height, so we're going to make it equal to 45, and then solve it. Now for this one, I'm not going to use my calculator, I'm just going to solve it. So I'm going to subtract 45, it's a quadratic equation, a simple one. Subtract 45, that's that, subtract negative 40. Factor it. The two numbers that multiply to negative 40 and add to 3 are positive 8 and negative 5. When I solve it, only the positive answer do I care about. So negative 8 in a real world situation doesn't make sense. So 2a, at what time is the height of the balloon 45 feet? And the answer is 5 seconds. B. B asks, how fast is the balloon rising at time 1 second? So when you're asked about fast, how fast it's rising, then you're asked about the velocity. So first I need to ask is find the velocity of it. So the velocity, simple power rule, 2 times 1 in front, subtract 1 to the exponent. 3t is 3, and a constant is 0, so there's the velocity. Then the question again says, how fast is it rising at 1 second? So I'm going to plug in 1, and then you have the answer. And now I need units. So the units for number 2 is feet and seconds. So it's 5 feet per second. So exactly at 1 second, the balloon is rising at a rate of 5 feet per second. C. In C, you're asked about how fast is the balloon rising at 4 seconds. So I'm going to plug in 4. 8 plus 3, that's 11. So it is 11 feet per second. Now, if you got a negative answer, all that's meaning is instead of rising at that moment, that's how fast it is falling in this situation. So something that's rising or falling, rising is a positive velocity, falling would be negative. If something is going forward or going backward, forward would be positive and backward would be negative velocity. D. In part D, what is the balloon's velocity when it is 45 feet high? So I'm going to take the velocity, make it equal. Oh, wait a second. First, I have to take the position. So the position is 45 feet high. So then I make that equal to this. Now, we already solved this, right? So I'm not going to redo it. So I'm take the position equal to 45. We said that is at 5 seconds. We already solved it. Then we take the velocity and plug 5 into there to know what's happening. So the velocity of 5 is 2 times 5 plus 3, so that's 13. So the answer is 13 feet per second. Done. Just working with position, velocity, and acceleration. Number 3. In number 3, a ball rolls on an inclined plane with that position. So we have, again, it's a real world situation. So we're not going to have the time being negative. After that, it says find the ball's velocity at 2 seconds. So that is the position. The velocity would be the derivative of the position, 3 times 2. Subtract 1 to the exponent, 2 times 3. Subtract 1 to the exponent, and then 5 would be 0. Then it says at 2 seconds. So then we're going to plug in 2. Make sure you're aware of the units when you do that. So it is 36, and the units are in centimeters per second. Part B, when is the velocity of the ball 30 centimeters per second? So the velocity is 30, so we take the velocity, make it equal to 30, and then I'm going to solve it. So I'm going to subtract 30 to make it equal to 0. I'm going to divide everything by 6. So if I divide everything by 6, it's t squared plus 1t, subtract 5. Now, what I notice about this is that it doesn't factor. So I'm going to use my calculator. So I want to solve this. So I didn't really need to simplify it if I was just going to use the calculator, but I didn't see it right away that it wasn't factorable until I reduced it down. All right, how do I solve again? So here we go. See if I can get a little more light into this, so you can see it a little bit better. So we are going to go menu. We are going to go algebra and solve. Just trying to brighten it up just a little bit if I can make it a little brighter. All right, so take that. I know I got some lighting challenges here. So take that. Now it just went completely dark. See if I can bring it back again. Oh no. What am I going to do to try to lighten it up so that you can see it? Maybe this is an issue. Or maybe it's my computer. Let's try it. Alright. So, it's still really dark. I'm doing everything I can so it's not dark. Makes me sad. So for whatever reason, it's not liking the lighting right now in my room that I'm doing it in. But anyways, I'm going to solve it nonetheless. I'm going to show it as close as I can to it so that you can see it. So I'm going to press again, solve. I'm going to press, so you press algebra, then solve. My goodness, what am I going to do here so that it will recognize like the lighting of something? Oh, maybe that worked a little bit better. Or not. So, if I'm going to solve this, let's type it in. What are we typing in? T squared. You can use T. So go T, and there's a squared button right beside the exponent button. So you just go T squared plus T, subtract 5, equals 0, and then comma T. So underneath the pi is the comma, then T. So I don't know what I'm going to do with this portable hover cam that does not want to recognize the light of it right now. So I will tell you that the answer is 2.791, and I'm not going to use the negative one. So back here, for this situation, I have 2.791 seconds when I use the calculator. I also have a negative answer. Oh, that is the negative answer. I can't even read it. It's getting there. So it's 1.791. That's the positive answer. So both understanding and knowing how to use it at the same time, and having to use your calculator when you have to. And again, the rule for AP exam, 3 numbers to the right of the decimal when you do it. All right, there's 3. Let's try 4. See if I can figure out the lighting in here so we can make it work for 4. Or I might have to do it again and see if we can make it adjust that way. So I can't get it. It's completely dark, even though I know it's not dark here. So I'm going to try part 2 of the video to see if I can lighten it up somehow by rebooting something. All right, Mr. GMath, I'm coming back.